We're back with part two of constructing and interpreting two-way frequency tables. Yesterday we had the information given to us in the form of a table. We were missing a little bit of the data there, missing some of the boxes. We had to use a little bit of subtraction to figure out what the answer was, what was missing. We're going to do something a little bit different. We're going to need to make and fill out tables based on the information we're given. So if you notice down below here, we've got a frequency table, but there's nothing in it. The information is in the paragraph right here. Same thing here. We've got some information over here. We're going to have to fill this out. We may or may not have to change these into relative frequency tables, but notice on number 9 here, this is one from your assignment, there's not even a frequency table set up for us. So we're going to need to think about how to do that particular problem. So I'm going to slide back up here and let's go ahead and let's take a look. One thing I'd like you to take note of before we get started is that the numbers are sometimes written in words rather than in numerals. So occasionally they're written in numbers. You can see a number right here, but there are times where they will actually, spell out the word 40 instead of writing the numeral 40. And the other thing is, make sure you make the correct type of table. If it's a frequency table, we're just using the numbers, or a relative frequency table, then we're going to be using the percents, or they may ask you to do both, so keep your eye out for that. So here's the first problem. This is example number 2 from 12.4. It says Mr. Smith kept track of his students missing assignments for 1 month. He put the girls and boys who missed an assignment in 2 categories: first-time offenders and repeat offenders. So people that had only missed, 1 assignment so far, and then people who had missed more than 1. He lost his original data and needs to recreate a two-way frequency table. He knows the following: 40 students missed the assignment in total. So he remembered what the table total was. 8 boys and 2 girls missed an assignment for the first time. So there weren't very many boys or girls that missed for the first time, so he could remember that. And then this number stuck in his head. This is a weird one. 77.5% of the total number of students who missed assignments were boys. Let's think about that. Okay, let's put the information that we know for sure. It says 40 students missed assignments in total. So that means that's the table total. So we're going to put a 40 right here. It says 8 boys and 2 girls missed an assignment for the first time. So 8 boys and 2 girls. That means we're going to put 8 boys and 2 girls in that first time category. Gosh, that means we can fill this in. So this is going to be 10 right here. Well, wait a minute. We haven't even used this other piece of information, and we know this, that we know this has got to be 30 right here. So we've already got a whole bunch of stuff filled in. Let's see what this other piece can do for us. It says 77.5% of the total number of students who missed assignments were boys. So the boys, the total for the boys, it was 77.5%. So we want to do 77.5% of the 40 students total. Remember, of means multiplication when we're doing a percent problem. So this is going to be 0.775 times 40. So let's grab a calculator and figure out what that is. So clear this off, 0.775 times 40, and we end up with 31. That means 31 of the people who missed assignments were boys. Well, that tells us something important, because if 31 of the 40 were boys, that means 9 of the 40 must have been girls. And once we have this, then we can fill in the missing information. So if this is 2 and we add this and we end up with 9, this must have been 7. If this is 7 and we add this and we end up with 30, this must have been 23. And here's our double check. We use this row and this column. Let's check this guy right here. 8 plus 23 is 31, so we've got the right numbers. Okay, there is our frequency table. Now let's see what type of questions they ask. How many students missed more than 1 assignment? Missed more than 1 assignment. Well, those are not first-time offenders. We actually answered this one really quickly. Early on, we knew that if this added up to 10 and the total was 40, that had to be 30. So the answer on that one is 30. Then it says what percent of the students were girls who missed 1 assignment, and the second part of that question is boys who missed 1 assignment. So let's take a look here. Now, we don't have to go through and make an entire relative frequency table. We could just do this. What percent of the students were girls who missed 1 assignment? Girls who missed 1 assignment. Well, there were 2 girls who missed 1 assignment out of 40, so this would be 2 out of 40. Let's grab the calculator and figure out what percent that would be. 2 divided by 40, you might know what this is already. That's going to be 0.05. Move it over 2 places, so that's going to be 5%. So we'll put 5% there. And same question, except for now it's boys. Boys who missed one assignment. So boys who missed one assignment, that's going to be 8 out of 40. You may know what that one is also. I'm going to grab the calculator. 8 divided by 40. We hit enter and we end up with 0.2. Moving that over 2 places, we end up with 20% of them. So about 25% of the kids had only missed one assignment. And if you take a look right here, these two, this 5% here and this 20% here, would add up to 25%, and 10 is 25% of 40. So that looks great. We've got the answers to that one. Now let's take a look at the problems down below. Number 3 is on your assignment, so let's take a look at this. You'll notice that we've got some information, some raw numbers given here. We've got a frequency table here, and notice it's got a percent here, so I suspect that this is going to be a relative frequency table. And let's take a look. It says you randomly surveyed students about whether they will dress up for Halloween this year. Use the data to make a relative frequency table. So we don't have to do 2 of these. I've got quite a bit of space here. This is what I'm going to do. 7th graders, 38 dress up, 10 do not. So I'm going to do a 38 right here. 38 dress up, 10 do not. That would be a total of 48. 8th grade, 19 dress up, 16 do not. So if we add those together, that would be 35. And then let's see, 9th grade, 7 dress up, 10 do not, and that's going to be a total of 17. So let's go through and add these up. Now I'm going to grab a calculator to do these really quick, make sure we get these right. So this is going to be 38 plus 19 plus 7, and we get 64. So I'm going to put a 64 right here. Now notice I'm keeping these up in the upper left hand corner of the box. I'm not taking up too much space. Let's do the next one. 10 plus 16 plus 10. We probably could have done that in our head. So 36 here. So this is 36. And then let's add the 64 plus the 36. So I'm going over this way right here. Add those together. We'll look at this. We get 100. Okay. Now, as a double check to make sure that we did this correctly, let's total this row and make sure that that adds up to 100. So we're going to do 48 plus 35 plus 17, and we get 100. So this looks like the right numbers. So in order to change these into a relative frequency table, we're going to take each one of these numbers and divide by the table total. And I think you'll notice something really nice about this. We're going to divide every one of these by 100. I've written them all so they're divided by 100, and the cool thing about this is we know what happens when we take 38 and divide it by 100. If you wanted to double check on your calculator and you're a little rusty from 7th grade, we get 0.38, which if we move it over 2 places is 38%. Well, remember, percent means per 100, so this is 38 per 100. That's going to be 38%. This is 10 per 100. That's going to be 10%. 48 per 100. That's going to be 48%. And look at this, they add up to be 48. So the cool thing about this particular table is because the total for the table, because the table total is 100, every one of these is just going to turn into a percent. So this is going to be 19%. So now they're all there in percent form. Let's go ahead and answer the questions. It says, how many students were surveyed altogether? Well, that's a question about how many students, and this is what made this easy. The fact that there were 100 were surveyed. What is the relative frequency of 7th graders who dressed up? 7th graders who dressed up. So let's see, that's going to be the 38% right here. So 38%. Relative frequency of 8th graders who dressed up. That's going to be 19%. And then 9th graders who dressed up, that's going to be that 7% right there. Now, this is something that may not be perfectly obvious as to what goes on here. It says, what do you notice about the percent of students who are dressing up in each grade? Now, the numbers definitely were going down, but they were both going down, at least here. They went up a little bit in the do not dress category, and then they went down. We didn't survey as many 9th graders, so we would expect these numbers to be smaller, but this is a huge drop-off. We went from 38% to 19% to 7%. So huge drop off. If we do look at this distribution right here, 64% of the students that were surveyed dressed up, 36 did not. That's a little bit misleading because there were so many 7th graders that were surveyed. This is another reason why dividing by the table total maybe will give us a little bit of misleading information. But what do you notice about the percent of students who are dressing up in each grade? We're just going to say this: it goes down every year. Okay, that's probably the best conclusion that we could make based on the information that we've got there. Okay, that's number 3 from your assignment. Let's take a look at number 9, and this is the one that we're missing the frequency table, so we're going to have to construct one from scratch. It says Chad collects data about a number of people who own a smartphone, and if they also own an MP3 player. He gives you the following information and asks you to make a two-way frequency table. So frequency table here. 25 people surveyed own a smartphone. 20 people that own a smartphone do not own an MP3 player. 9 people do not own a smartphone, but they do own an MP3 player. 24 people do not own an MP3 player. Okay, there is a ton of information there. This is the first one where we have to take all of that information and construct the frequency table. So let's think about what's going on. This is called a two-way frequency table because there are two ways to describe the people. So they either own a smartphone or they do not own a smartphone. So for that part of the survey, it's just yes or no on smartphone. The other thing deals with an MP3 player, and you'll notice that in some places they say they do not own one, and maybe they do own one in other places. So that is a yes or no. So it's either yes, they have an MP3 player, or no, they don't. So here's what we're going to do. We're going to do a table just like the ones up above. Now I'm going to start off with this right here. We're going to have 4 boxes in here, and this is going to be smartphone, and this is going to be MP3 player. All right, now this is a yes or a no. So yes, no, and same thing over here, yes, no. Now we're going to be able to fill these in right here, but we also have totals over here. So let's make space for that. Now this isn't going to be very pretty, but it is going to be relatively effective because what we're keeping track of is just whether or not they have a smartphone, yes or no, whether they have an MP3 player, yes or no. And the reason we added these is because those are the totals. So we're going to put a total down here. So you'll notice that this is structured just like what we had up above. Not very pretty, but it'll cut it. So let's take a look. It says 25 people surveyed own a smartphone. So own a smartphone. Smartphone, yes. Now it doesn't say whether or not in that piece of information whether or not they own an MP3 player. So we're going to put 25 down here. Another way to say that is 25 people total who were surveyed own a smartphone. 20 people that own a smartphone do not own an MP3 player. So if they own a smartphone, then 20 of them do not own an MP3 player. So 20 do not, so no on MP3 player. So the 20 is going to go right here. And as we go through and do this, you might notice that we can fill in some information. This is going to be a 5, because if the total is 25 and 20 of them did not have an MP3 player, then 5 of them must have had an MP3 player. I'm going to change back to the other color. 9 people do not own a smartphone, but they do own an MP3 player. So that would be no on smartphone, but yes on MP3 player. So I'm going to put a 9 right here. And then it says 24 people do not own an MP3 player. 24 people do not own an MP3 player. So that's just no, I don't own an MP3 player. That's not answering the other question. So this is going to be a 24 right there. Now, once you have that, you'll notice that we can figure out a bunch of information. Once I put that 9 there, we can actually add those together and we get 14. Once I put the 24 here, we can do a little subtraction problem and say, hey, 20 plus what equals 24? That's going to be a 4. And then we'll go through and add these up. That's going to be a 13. We're going to add this way. 25 plus 13 is going to be 38. And here's the double check. Is 14 plus 24, does that equal 38? It does. So we've got all the correct information. Now we can answer the questions. So it says, how many people were surveyed? Well, that's asking for the table total. So that's going to be 38. What percent of those surveyed own a smartphone? So what percent own a smartphone? So that's just smartphone and yes, I own a smartphone. So that's going to be 25 out of 38. So let's figure out what that is on the calculator. We're going to do 25 divided by 38. It says what percent. We're going to round to the nearest tenth. So that's going to be 65.78. That 8's going to bump that up, that 7 up to an 8. So this is going to be 65.8. 0.8%. 65.8%. So there's our answer on that one. There's our answer on this one. And again, 25 out of the 38 people surveyed, that's a pretty high number out of 38, so we'd expect a relatively high percentage. And now we'll take a look at the last question. It says, what percent own a smartphone and an MP3 player? So those people need to be yes in both categories. They need to be yes, I own a smartphone, and yes, I own an MP3 player. So that's only 5 out of 38. So we'll grab our calculator. We'll do the 5 out of 38. 5 divided by 38. Hit that divide button. 38. 5 divided by 38. And we get 0.1315, so that's going to be 13.15%. That's enough to bump that up to a 2, so this is going to be 13.2%. All right, we might be able to look at this and kind of determine some other patterns, but these are the only ones that they asked us to. Again, two-way frequency tables, great way to organize information. Now we're going to take a look at number 8 from your assignment. So I've got 12.4b up here, two-way frequency and relative frequency tables. Please make sure you read the information carefully before you fill out the table. And on a couple of these problems, we're actually going to have to make the chart itself, make the table itself. So you want to make sure that you think about it and make sure that you're doing it right before you start just blindly putting stuff in. And then make sure you answer the questions on each problem. So we're going to flip over to the other side and we're going to take a look at number 8. So here is number 8. It says 80 children went on a school trip to either Salt Lake or Provo. 50% of them were girls. 12.5% of them were boys who went to Salt Lake City. 25 girls went to Provo. Use this information to design and complete a table. You can make a frequency table or a relative frequency table. It doesn't matter which one you do on this particular problem. So let's go ahead and do this. Let's figure out how many categories we've got here. They had two destinations. They could go to Salt Lake or Provo. So I'm going to do SL and I'm going to do PR. Okay, so that's Salt Lake or Provo. We've got those two categories. And then the only other categories were whether they were girls or boys. So I'm going to do girls here and boys here. So we've got this. Now I could just do a box like we did before with just 4 boxes right here. But remember, we're going to have a total for each one of these. So I'm going to come down here and I'm going to go like this. So there's the girls, there's the boys, and we've got a column total or a row total here, and then we're going to have a column total for each one of these. Okay, so let's take a look here. 80 children went on the school trip. Well, 80, that's the number for the total. That's the table total. So I'm going to go ahead and put 80 here. 50% of them were girls. 50% of them were girls. Well, if 50% of them were girls, that would be 0.5 times 80. That's going to be 40. So 40 of them, half of them were girls. Well, that automatically means that the other half had to be boys. So I'm going to put 40 right here. Okay, so that's great information. We're not even done with the first line. 12.5% of them were boys who went to Salt Lake City. Okay, 12.5%. I'm going to move the decimal over there. So this is going to be 0.125 times 80. I'm going to grab the calculator and figure that out. I am hoping that a couple of you recognize 0.125. That was one of those common rational numbers that we talked about in 7th grade. So times 0.80. Or times 80, 10. So this ends up being 10. 0.125 is an eighth. So an eighth of 80, we'd expect that to be 10. And again, those were boys who went to Salt Lake. Boys who went to Salt Lake. So that's going to be a 10 right here. All right. Well, hey, wait a minute. We can figure this out then too. We can figure out the fact that if this is 10 and this is 40, that's got to be 30. And then it says 25 girls went to Provo. 25 girls went to Provo. So I'm going to put that number right here. So this is going to be a 25 right there. Now, the cool part about this is they gave us this information. They actually gave us, of these 9 boxes, they only gave us the red ones, but we can figure out the rest of them because of where they're placed. So let's go ahead and figure this out. Let's add these guys together. So this is 25 plus 30. That's going to be 55. So 55 right here. Let's figure this one out. If I had 80 and 55 of them went to Provo, that leaves 25 that went to Salt Lake. And if I do a little bit of a subtraction problem right here, 25 total, 10 of them were boys. That means 15 of them were girls. Let's double check this. 15 plus 25, does that equal 40? Yes, it does. 10 plus 30 is 40. 25 plus 55 is 80. Everything checks out here. Everything adds up like it's supposed to. Which destination was more popular? Well, if we're just talking destinations, we're going to ignore the girl-boy thing and we're just going to look at Salt Lake and Provo. It looks like Provo was more popular. So we're going to write Provo here. Okay, and we're going to say 55 out of 80. 55 out of 80. So that's pretty good. Which destination was more popular for girls? Okay, so we're just looking at girls. Which was more popular for girls? Let's see. So of the girls, 25 versus 15. So more girls went to Provo. Okay, so this is going to be Provo again. Provo, I guess I should write Provo rather than prove. So let's see, 25 out of 40. And then let's take a look down here. Which destination was more popular for boys? For boys, let's see, looks like Provo also, 30 out of 40. So Provo also here, and 30 out of 40. Now, on these problems right here, when it says which was more popular for girls, what we're doing there is we're kind of doing what's called a conditional distribution or a conditional frequency. We're just saying, look, for the girls, so ignore everything else on here. So we're not worried about the boys or what the table total is. We're just worried about these guys right here. And same thing for boys. We're just worried about these guys right here. And on this particular one, it really wouldn't matter because overall Provo was more popular, and it was more popular for the girls and the boys. There wasn't some overwhelming number in each one of these, and these were equally weighted, and sometimes it works out like that. So keep these details in mind. Work hard on this. It is worth getting figured out. Two-way frequency tables are really awesome. They can be complicated at times, but I know if you stick with it, you can get it. Good luck.